with questions from your homework. We'll look at 1.1 first. So any questions out of 1.1 that you'd like me to go over with you?
2, 5.
Okay, so 2 and 5. Okay, any others besides 2 and 5? Okay. What about then 1.2? 1.2 is the application, so we'll probably have more questions out of 1.2.
But actually, can we do in 9 and 10 on 1.1 the same answer?
I believe so. Yeah, those are just rewritten. They'll come out to be the same answer. They just look a little bit different from the beginning. But yeah, I can look at one of those if you like. So just to make sure we can solve it, I'll add 9 to the list. But 9 and 10, yes, when you break them down and move everything around, they should come out to have the same answer. Okay, so that's 1.1. Questions out of 1.2 now. Anything out of 1.2? We got plenty of time. I can set them up. Which ones?
You do 2, 6, 7, 11, and 13.
And 13. Okay, so we've got 2, 6, 7, 11, and 13. Sure. Are there some others that you would like for me to add to the list?
1.
Sure, we can look at question number 1 as well. And some of these I may not work out completely, but I'll set them up and make sure you know how to get the equation from the table. But I may not work them out all the way through, but at least I'll make sure that you've got them set up correctly. Okay. Any others out of 1, 2 to look at? Anything else? All right, well, then we'll go ahead and begin with 1.1. And when we're working these out, if you've got any questions, be sure and ask. Because I'm here, we can slow down, we can look at things, we want to make sure that you know how to work these out. Okay, so we're in 1.1. We're going to begin with question number 2. Okay, question number 2 is solving an equation, and this equation has square brackets and it has parentheses. So just write the problem up here, and then we'll solve it. Now remember, when we talk about equations, there's 3 different types. There's conditional, meaning we get an answer, right? There's identity, where they match up, where they're exactly the same. And there's a contradiction, where it just doesn't make sense. So like 5 equaling 11, that would be a contradiction. When we come up with this type of problem, we want to begin inside and then work our way out. So we're going to begin first by distributing that 7 through. And that leaves you then with 3x plus 5 plus 7x plus 7. And that still equals 7x plus 5. Now inside, we'll go ahead and combine like terms. So let's go ahead and combine those together. So that leaves me then with a 10x inside. And we've got a 5 and a 7. That makes it a 12. Make sure we wrote everything down correctly here. Always double check. It's so easy to make a mistake. We still have that 4 out in front. Now square brackets behave exactly the same as parentheses. So we'll distribute that 4 through. And that leaves you then with 40x plus 48 equals 7x plus 5. And we want to move things around so we can solve it here. So we'll go ahead and move that 7x over. And then move that 48 over as well. So that leaves you then with 33x on the left-hand side. On the right-hand side, we have, looks like a negative 43. We'll divide by our 33. And that leaves us with our final answer of x equaling then a minus 43 over 33. Oops, everyone all right with that so far? And we're not going to break it down into decimal. We're going to leave it as a fraction. So don't break that down. Just leave it as it is. Okay. So that was question 2. Question 5, we've got an interest problem. Now, on question 5, what's very important is the time. When we talk about question 5, we have to make sure that our time is in what? In terms of years. So if it's in months, what do we have to do? Divide it by 12. Okay? So we'll read the problem, we'll identify the pieces, and then answer the question. So question 5 says, Sophia borrowed $12,109 at 4.5% simple interest for 6 months. How much will the interest amount to? And what is the total amount she'll have to pay back at the end of 6 months? Our interest formula is this. Our interest formula is I equals PRT. P is the principal or the starting amount. R is the rate. And we want that as a decimal. And T is time in years. So we have to make sure that we convert that. So what do we have for our starting amount? Well, our starting amount is going to be that $12,109. So that's our P. Our interest rate is 4.5%. We need to convert that to a decimal. And so that would be 0.045. And the time, well, what do we have? We're not running this for 6 years. We're running this loan for 6 months. So that's going to be 6 over 12, which reduces down to what? It's going to reduce down to a half, isn't it? Is everyone all right with that so far? Most commonly made mistake is someone will use 6 for the time. We're not using 6 years. We only want half of a year. So now we fill in our formula. So I equals then 12,109 times 0.045 times a half. And you could use 0.5 or you could just use the half there. I'm going to go ahead and multiply all the numerators together. So we'll take our 12,109, multiply that by 0.045, and then multiply that by 1. That gives you 544.905. We're going to then divide that by 2, and that gives us our interest, which is then to the nearest cent, $272.45. So that's part of our answer, and that's how much the interest is. Now we need to make sure that we answer the whole question. So that's our interest. So how much is the total amount going to be? Well, the total amount is going to be that 12,109 plus 272.45. Adding those together, then we get our total amount to be $12,381.45. Is everyone okay with that one? Everyone see how that one's working? Question 7 and 8 are very, very similar. 9 and 10 come out to give you the same answer. They look a little bit different, but you're going to get the same answer. And these are what are called literal equations. And what's a literal equation? Well, a literal equation is simply an equation that has more than one variable. And so on literal equations, I have to tell you what variable to solve for. So for question 9, we've got 7 equals 4x minus 9y. And we want to solve this for the variable y. We'll do this a lot in chapter 2. When we work with graphing equations, we'll be solving for y all the time. So we need to make sure we can solve an equation for y. So we'll move that 4x over. And then I'm going to put the 9y, the negative 9y, I'm going to put that on the left, just so it's easier to work with. And then on the right, I have a minus 4x plus 7. Now I can divide both sides by that negative 9. What you do not want to have happen is a negative down below. So if you have a negative down below, what we can do is we can bring that negative up to the top and change our signs. So when I rewrite that with a positive 9 below, I am left then with y equals now, negative becomes positive, so that's going to be 4x minus 7y over 9. And that should be the same answer that you get for question 10. You might just have it in a different order on 10, but it's going to be the same. And we always bring that negative from the bottom up to the top. And you can split this into 2 separate pieces if you would like. But right now, we'll just leave it in one fraction. Are there any other questions out of 1-1? Which one?
The answer for 14, negative half.
Oh, let's see. I don't have the key with it. We can go ahead and work it out, just to make sure, though. And 14, there's a couple of ways we can do 14. So I'm going to show you 2 different approaches to 14. Now, one approach would be to do this. One approach would be to break everything up into an individual fraction. And we can clear out our fractions by looking at our denominators. What do we have in our denominators? We have a 3 and a 7. And that means they have a least common denominator of a 21, right? This is one way of doing it. I'm going to show you how to cross multiply after this. So we could multiply all of this then by a 21. And we'll distribute it through. And when we clear our fractions, what do? Divide by the number down below, right? Multiply by the number on the top. So 21 divided by 3, that leaves you with a 7x. 21 divided by 3 is a 7, times 2 makes it 14. 21 divided by 7 makes it a 3. The x stays with it. And 21 divided by 7, that's a 3, times 4 makes it a 12. Fractions are gone. Move the x's over, and we're done. So we're going to move that 3x over with subtraction, And we'll move that 14 over as well. Now we have 7 minus 3. That makes it a positive 4x. The 14's cancel. The 3x's cancel. And 12 minus 14 leaves you with a minus 2. So you got to watch your signs here. Divide by your 4. Reduce it down, and you get your answer of x equaling a negative 1/2. Right? So watch your signs there. So that's one way of doing it. How else could we solve this problem out? We could also solve by using what's called cross multiplication. And in some cases, it's a little bit faster. So we're going to solve it again, but this time we're going to use cross multiplication. So to use cross multiplication, we've got x plus 2 over 3 equals x plus 4 over 7. And this is a technique that works when we have a fraction equaling another fraction. Okay, we got a fraction on the left, fraction on the right. What we can do is we can clear our fractions by cross multiply. So when I cross multiply, then I get 7 times x plus 2 equals 3 times x plus 4. We should get the exact same answer as we did on the previous question when we worked it out. And that leaves me then with 7x plus 14 equals 3x plus 12. Move the 3x over. Move the 14 over. And we end up with the same result because we still end up with 4x equals now a negative 2. We'll divide by our 4 and we're going to reduce it. And that leaves you with x equaling then a minus 1/2. Okay, two different ways of solving the same problem. And when can we use cross multiplication? When you have a fraction equaling another fraction. What type of equation is this? Is this an identity, contradiction, or a conditional equation? This will be conditional. Why? Because we have an answer. When we solve it, we get an answer. It's called conditional. Now we'll move on to 1.2. And 1.2 is application. And I'm not going to work most of these out completely, but I'll work them out at least to the step where you can finish it. At least the setup part. So now we're going to look at 1.2, and we're going to begin with question number 1. And we'll need a formula for question number 1 in the back cover of our textbook, I believe. So we'll read through the question, see what we're working with, find the correct formula, and then work it out. So a circular hole is filled with concrete to make a footing for a load-bearing pier. The ground measures 15 inches across, and it requires a bag and a half of concrete to fill. What is the depth of the hole? And one around to the nearest inch. And it even gives you a hint that one bag of concrete makes 1,800 cubic inches of material. So first off, let's see what we've got, what we're working with. We're going to dig a circular hole in the ground. So if we dig a hole in the ground, it's going to look similar to that, right? So that's what we've got. And this, by the way, is question number 1. So now we need to go to the back cover of our textbook. And we'll look at the geometric figures here. And we'll see which one we need to use. Well, what does it look like? It looks like when we work through these, looks like a right circular cylinder, doesn't it? So we're going to be using the formula here for the right circular cylinder. So that's what we've got. Now we do need to make sure when we use this formula that we use the radius, because this is in terms of the radius here. We've got the diameter though. So we know we're going to use this formula. Now, which one are we going to look at? We're going to look at the volume. Why are we going to look at the volume? Well, we're looking at the volume because it says one bag of concrete makes 1,800 cubic inches of material. And cubic inches is a volume. So we're going to need to use the volume. So let's write up our volume formula, and then we'll apply it. So our volume formula is V equals pi r squared h. Now we do have to be careful when we work with this problem because we're not given the radius, we're given the diameter. Remember, the diameter is the distance across, and the diameter in this case is 15. So that means my radius, r, is 15 over 2, which is then 7.5. And we can use decimals because it says round. So we can go ahead and turn these into decimals if you would like. Now, what do we know? We have 1.5 bags of concrete, and we know that each bag makes 1,800 cubic inches of fill material. So that means that 1.5 times our 1,800 gives us our total volume, which is 2,700. So that's our volume. So we've got all of our pieces laid out. So we had to take our diameter, we had to half it because we want the radius. Then we took our 1.5 bags of concrete and multiplied that by 1,800. Now I'm going to put everything back into our formula, and you can finish it from here. We're trying to find our height. So what do we know? When we use our formula, we know now our total volume is 2,700. So that goes here, equals pi times 7.5 squared times h. We can go ahead and finish it. I think I can leave this for you to work out, though, right? Use your pi key in your calculator. Take that 7.5 and square it. And then you'll take your 2,700, divide by everything else, and you'll get your value for h. Now, what do we want to do? We want to round to the nearest inch. So we want it just to the nearest inch. So you'll find out whatever it is, round to the nearest inch, and then label it. But you should be able to finish it from here. So just use the pi key in your calculator, square that 7.5, and divide. Is everyone all right with the setup on that one? That one we just had to kind of use a formula from the back cover, figure out where all the pieces went. Question 2. Question 2 is a mixture problem. In a chemistry class, 6 liters of a 4% silver iodine solution must be mixed with a 10% solution to get a 6%. How many liters of the 10% solution are needed? So we're going to draw our diagram first. And we're going to label it box 1, box 2, and box 3. And box 3 is what we want at the end. Each of these has an amount and a percentage rate. So in a chemistry class, 6 liters of a 4% solution. So that's what we're going to start with here. This is where we start. We're going to start with 6 liters of a 4% solution. And then we're going to take that and we're going to mix it with a 10%. But we don't know how much is in there, so we're going to use an X. And our percentage rate is 10. We add across, because remember, 1 plus 2 is 3. So those add together, and that gives you X plus 6, or 6 plus X there, either way. And what percentage do we want to have at the end? When we're mixing these together and we're done mixing them, we should get the 6%. So 6% is going to go in box 3. Why? Because that's what we want at the end. So we started with 6 liters of a 4% solution. We're going to add on an unknown amount, X, at 10%. And we want to end up with the 6% at the end. So the amounts add together. Now how do we build our equation? Well, our equation is built off of the pure. And the pure is simply the amount times the percentage rate. So let's see what we have. We have amount times rate. So that's going to be 6 times 0.04 for your first one. It's those two going together. Then we have 0.1 times X for your second one. And then on the right-hand side for the third part, what do we have? We have 0.06. And how much is in there? 6 plus X. And you should be able to finish it from here. So we've got it set up. You can finish that equation out. Okay? Is everyone okay with how I set that up? The most important part is to make sure that box number 3 is what you want at the end. So when we've solved this out, we want to make sure we get that 6%. So it goes in box 3. That's where the majority of students make a mistake, is in that box 3. Question 6. Question 6 is an investment problem. And we're going to be investing money. And it's very, very similar to the mixture problems. So we're going to look now at question 6. We'll read it. Sure. Did you have a question on one of them? Or?
No, just writing down.
Oh, yep, sorry about that.
Okay.
Yep, and if I go too fast, be sure and say something. So question 6 here. We're looking at investing. So we're going to invest some money at 2.75% and $4,000 more than twice this amount at 3%. We know our total annual income is $1,257.50, and we want to know how much went at the 3%. When we look at an investment problem, we have an amount, a percentage rate that it pays out, and then interest earned. So this would be like your bank statement. If you have a savings account at the bank, there's 3 things they have on there. How much money you have in that account, what percentage rate that it pays out, 0.5%, maybe 1%, something like that. And then it also tells you how much money you made in that quarter or that year. Now the amount is how much you have to begin with. And this over here is going to be our total amount. And we just add across. Not to be confused with the interest. Because if I have a savings account that has $10,000 in it, I only probably made $50 in interest, right? So big difference. So make sure you notice the difference between the amount and the interest that it paid out. So the amount's always a lot more. So we invested some money at 2.75%. Do we know how much money we have in there? No. So that's going to be our unknown amount, X, and we're going to use a 2.75% here. Then what are we going to do? Then we're going to invest $4,000 more than twice this amount. So that's going to be 4,000 plus 2x. And that is invested at 3%. So we want to diversify our investments here. Adding across, how much total money do we have? We have 3x plus 4,000. So just add those across. The only reason I put this here is so you don't put that $1,200 or sorry, $1,257 here, because it doesn't go here. This is the amount. Interest is what's next. How do we find our interest? Well, the interest is done exactly the same as we did the pure. So that's the amount times the rate. And so for the first one, we have 0.0275 times x. Where students make a mistake is a lot of times with that percentage. So make sure you use the correct number of decimals when you move it over. You've got to move it 2 places. So that 2.75% is 0.0275. And you all know that, but that's just a commonly made mistake because students get in a hurry. And it's easy to forget about a zero. So be very, very careful with those percentages. The next one is 3%, so that's 0.03. And that's going to be multiplied by 4,000 plus 2x. So that's your second account. And then on the right-hand side, we want the total interest. And this is given in the problem. And that total interest is $1,257.50. And you should be able to finish it from here. Now, I will tell you one thing. When you solve it and you find x, that value of x is not your complete answer. Why is that not your complete answer? Well, what does the problem want? We want to find how much we have at the 3%. What is x? X is not the 3%. X is the 2.75%. Right? So what we're going to have to do is find x, multiply it by 2, and then add 4,000. And that's going to give you the 3% amount. So when you work this out, don't just stop at the x. Find both of them, is what I usually like to do. And then just circle the one at 3%, because that's what we're trying to find. But that's a commonly made mistake too, is students get the x, they stop, and they don't finish it. So we're right with that one. We'll move on then to the next question here, question 7. This one's a little bit different, but again, it is still an investment problem. So what do we know here? We know we've got $5,000 total. So Kevin invested part of his $5,000 bonus in a CD that paid 2%, and the remainder in mutual funds that paid 4%. If his total interest for that year was $190, how much did Kevin invest in the mutual funds? So we'll need to set this up. And this one's going to be a little bit different. Now, how is it a little bit different? Well, when we put these together, this is our total amount over here. How much total money do we have to work with? Not the interest. How much should we get for that bonus? Well, for that bonus, we got $5,000, right? So that's going to go there. That's our total amount. So the total amount of money that we have to work with is the $5,000. Not to be confused with the interest. They're completely different. Now we want to invest this in two different ways. We're going to put part of it in a CD at 2%. So we don't know. So we use an X. Percentage rate here is 2%. Now, what about the next one? We're going to put money in a mutual fund. Do we know how much we put in that mutual fund? No. Now, we can't just use the X again. So what we're going to use here is we're going to use 5,000 minus X. So why do we have 5,000 minus X? Because the side should be the same. And if we put these together, what happens to our X's? They cancel. We got 5,000 equals 5,000, right? So we need to make sure we preserve our equality there. Here's an example that might make more sense to you. If I go to the gas station and my car holds 15 gallons of gas, and I go to the gas station and I put in 10 gallons of gas to fill it up to the max, how many gallons did I have to start with? We had 5, right? Because you need, your tank holds 15 to fill it up. You added 10 in, so that means that difference is what? 5. How did you find that? You took the total size of the tank, which in this case was that 15, and you subtracted off that 10 to give you the 5. Same concept here. At 5,000, that's like how many gallons your tank would hold. X represents how much you put in. And when you subtract off those and put them together, you get that 5,000. So they should equal out. The X's will cancel. You'll get 5,000 equals 5,000. So just to make sure we know, one of these is going to be called X. The other one is what? Total minus X, which in this case is 5,000 minus X. So that's your total minus X. When you don't know either one of them is X. The other one is your total minus X. Now let's work with our interest. And how do we find our interest? Interest is the amount times the rate. And we'll label this as 1 and 2 here. And so let's label these out. We've got the unknown amount, X, at 2%. So that's 0.02X. Then we've got 4%. That's 0.04 times 5,000 minus X. And it doesn't equal $5,000. We want our total interest, which is $190. And you should be able to finish it from here. So there's your equation. Hopefully it's starting to make a little bit more sense on how to set these up. And the setup is always the hard part. Solving them, students usually don't struggle with. It's just the setup. We've got 2 more, and then we'll take a short break. So we're going to look now at question 11. 11 is very, very similar to 7. It's just that on question 11, we're mixing chemicals together instead of money. The only difference is, instead of dollar signs, we use boxes. So 1, 2, and 3. Each of these has an amount and a percentage rate. And box number 3, remember, is what we want. So a chemist needs 80 milliliters of a 20% solution. Now that 80 milliliters of a 20% solution, which box is that going to go in? 1, 2, or 3? Well, that's what we want at the end, correct? Right? So when you mix them together, that's what we want. So that means the 80 milliliters of the 20% goes with box 3 because that's what we need to have. So that's why it's going in box 3. What are we working with right now? Well, when we work with this one right now, we've got a 16% solution and we've got a 32% solution. So those are the percentage rates. Do we know how much we have of the 16%? No, so that's unknown. Do we know how much of the 32 we have? No. We can't just use that x again. What does it have to be? Total minus x. Remember, that's going here. So that's going to be your total minus x. And what's my total? 80. So that's going to be 80 minus x then. So one is x. The other one is the total minus x. Now we can build our equation. Instead of interest, it's the pure. And pure, again, is the amount times the percentage rate as a decimal. So for the first one, we have 0.16x. So there's that piece. The second one is 0.32. That's 32% times 80 minus x. And what does it equal? 0.2 times 80. And you can finish it from there, right? And just so everyone remembers, I always send out the notes after class too. With the videos, so everything you see, you can view on Blackboard.
And so when you say pure, so then none of those, is it just like,
Okay, what the pure is like this. Let's say we have a salt solution, salt water solution. Okay, the pure represents the salt. So if I have salt water and I boil the water out, what's left over is the pure. So pure is, in this case, when you mix these together, we've got on this one, what we're looking at on this one on 10 is, it doesn't say what type, but this might be acid. So we've got like 16% acid solution. So there's 16% of its acid, the rest is water. When we look at the pure, we find out how much of that acid is in there. So if we had 80 milliliters, we would take that 80 times that 16%, and that would tell us how many milliliters of acid there is. And that's what we're looking for. So that's what pure is. It's if we take out the water component. Does that make sense now? The last question before we take a break is question 13. And question 13 is a distance problem. We have to be careful with distance problems because with distance problems, we have to know if it's addition, subtraction, or if they equal each other. We're going to have to draw arrows and see what happens. Now, when is it subtraction? It's subtraction when they overlap. If they don't overlap, it's addition. And if If they equal each other, like going to work and coming back home, they should be the same, so they equal. So Tom Quigg traveled 240 miles east of St. Louis. For most of his trip, he averaged 60. But for one period of time, he was slow to 20 due to a major accident. If the total time was 6 hours, how many miles did he drive at the reduced rate of speed? So what we've got is we've got a trip here, and that trip is going to be broken up into two parts. And we know our total distance is going to be, let's see here, 240. And our total time is 6 hours. Each of these are going to have a rate of speed and a time. And these don't overlap, right? They're two separate parts. So this is going to be an addition problem. You've got one half and then another half. And so let's see what we've got. For most of the trip, he averaged 60. So he's going along at 60 miles an hour. And then he encounters an accident. And then at that accident, he slowed down to 20. So we've got part of it at 60, part of it at 20. Think about what we just did a moment ago on the last problem, when we had that total of 80. We didn't know how much was in either fund, so we called one of them X. The other was the total minus X. So do we know how long we travel at 60 miles an hour for? Does it tell us? No. Okay, now, do we know how long we travel at 20 miles an hour for? No. But we do know something else. What do we know here? We know our total time is 6. So that means that your second one is going to be 6 minus what? X. Very similar to what we just did a moment ago, right? With the amounts. Instead of amounts, we've got times. Now we can find our distance. And what's your distance? Distance is the rate of speed times the time. So let's build our equation. And we know for our first one, we've got 60x there. For our second one, we've got 20 times 6 minus x. And what's our total distance? Our total distance is going to be what? 240. So now you should be able to finish it. When you find x, x is not going to be the answer because x represents the time at 60 miles an hour. And we don't want the time. What do we want? The distance. And it says we want to know how many miles you traveled at the reduced rate of speed. So we find our value of x. So let's say x was 3. If you found x to be 3, it's not. I don't think it might be, but whatever you find x to be, you'll take it, you'll plug it back in. So 6 minus 3 would give you 3. Multiply it by the 20, and that would give you how many miles you drove at the reduced rate. So x is not your final answer. X is just part of it. You got to take it, plug it back in. Find the time on the second part after the accident. Multiply that time by your rate of speed, and that's going to tell you how many miles you drove. So you have to do the multiplication, and that'll give you the actual miles. And that's what we want. All right, so anyone else have any other questions? Okay, we'll take a short break, and we'll meet back here at, let's say, how about 7:45? So try to meet back here at 7:45.